Welcome back, guys. Today we'll be using the properties of determinant to solve for x. Here we have an example where we're going to find the values of x given the determinant is equal to 0. So let me go ahead and write the matrix. So having this matrix, what I'm going to do is add the columns. So we can add the columns, column 1 plus column 2 plus column 3, and I'm able to create a new column 1, and I'm doing that because I'm able to see that adding the columns I will be getting x plus 3 in column 1. So the operation that I'm going to do is adding column 1 plus column 2 plus column 3. So adding this, I'm going to have x plus 1 plus 2, that's these 3, that gives me x plus 3. 1 plus x plus 2, that's another x plus 3. Then 2 plus 1 plus x, that is x plus 3. The remaining we're going to write as is. So let me write the 1, the x, 1, 2, 2, x. And then we're going to factor out the x plus 3 that is common in the first column. So yes, we can factor out of a column or row if we have the similar expression in this case, which is x plus 3. So that will be my next step. So when I factor out x plus 3, what's going to happen is that I'm left with 1s in column 1. So I am just going to have 1, 1, 1, then 1, x, 1, 2, 2, x. It's equal to 0. Now I'm going to perform row operations to get these to be 0. So just remember the whole point of me doing the row operation, row 2 equal row 2 minus row 1 is to get 0 under the first leading value, which is 1. Now, let me rewrite x plus 3. And the first row will remain the same. So I'll have the 1, 1, and 2. And of course, I am going to perform the row operation 1 minus 1, so that's 0. X minus 1, that is x minus 1. And 2 minus 2, that's 0. Now here I need this to be 0, so I'm going to perform another row operation, which is row 3 is equal to row 3 minus row 1. So row 3 minus row 1, that's what I'm going to do. And I'm doing this because I want to get 0. So 1 minus 1 is 0, 1 minus 1 is 0, and x minus 2, that leaves with x minus 2. And let me write equals 0, because that's what it states, it's equal to 0. Now when you have an upper triangle, this is an upper triangle, the determinant of this is multiplying the x plus 3 by the diagonal. That would be the determinant. So this diagonal, when I multiply, because they have an upper triangle, the diagonal multiplying will represent the determinant. So that is why I have 1 times x minus 1 times x minus 2. Then I'm not going to expand, I'm just going to simplify this. So by writing the bracket, I just have x minus 1 times x minus 2, because 1 doesn't affect anything. From there, I'm hoping you're able to see that I have the answer here, because now I will equate each bracket to be equal to 0. So I have x plus 3 equals 0, x minus 1 equals 0, x minus 2 equals 0. So equating each bracket to be equal to 0. So I have x plus 3 equals 0. X minus 1 is equal to 0. And x minus 2 is equal to 0. Solving, carrying this over the equal sign, so x is equal to negative 3. We're going to do the same thing here. Carrying this over, there's a sign change, so x is equal to positive 1. And carrying this negative 2 over the equal sign, so x is equal to positive 2. And that's it. Now another example, we're going to solve for x, given the determinant is equal to 0. So looking at this, I can do the same procedure where I can add the columns to get the same value in column 1. Now, we could have added the rows. We could have added row 1 plus row 2 plus row 3. You could have done that. But I'm just going to stick to adding the columns. So column 1 is equal to column 1 plus column 2 plus column 3. And doing this, I'm able to get the first column to be the same expression. So adding this, x minus 3 plus 1 minus 1, that's 0. So we're left with x minus 3. Then we're going to add 1 plus x minus 5 plus 1. So that will be x minus 4 plus 1, that's x minus 3 again. Then minus 1 plus 1, that's 0. So we're left with x minus 3. So you're seeing that we have the same thing in column 1. And what we can do is factor it out. So if you had add the rows, then you would have the same x minus 3 in the first row. And you would factor out x minus 3 in the first row. So factoring out this x minus 3 in column 1, just as before, where we will have column 1 to be all 1s. That's what's going to happen. So factor out x minus 3. So we have x minus 3 on the outside, and then within we will have the first column being all 1s. So I'll have 1, 1, 1, and then 1 x minus 5, 1, negative 1, 1, x minus 3, and it's equal to 0. Now I'm going to do row operations, because the first row, I have the first row, first column, I have a 1, so below it I need zeros. So for row 2, I'm going to say row 2 is equal to row 2 minus row 1. So I'm going to do a row operation in order to get the 1 in the second row, first column, to be 0. So 1 minus 1, and then this is also a 1, so it means I'll need another operation, which is row 3 is equal to row 3 minus row 1, because that's where I'll get zeros, and I'm trying to get my upper triangle. So I'm going to do this. So I rewrite my x minus 3. And remember, we're not doing anything to row 1. So we're going to write row 1 as is. So we have 1, 1, negative 1. Time for our operations. So the row operation that we have is row 2 minus row 1 to get the 1 to be 0 in row 2. So 1 minus 1, that's 0. X minus 5 minus 1, that's x minus 6. And 1 minus and minus gives a plus, so 1 plus 1, that gives me 2. row 3 minus row 1, that's a mixed operation. So 1 minus 1 is 0. 1 minus 1, that's 0. And x minus 3, negative and negative, that's positive 1. So x minus 3 plus 1, that is x minus 2. So again, we have the upper triangles format. So therefore, the diagonal, leading diagonal, when we multiply that, that will give us the result of the determinant times what we have outside, just like the one that we did before. So this is just ensuring that we understand the last activity I did. So solving, I'm going to have x minus 3, the x minus 6, and x minus 2. All of them will be equated to be equal to 0. We don't need to expand this. Expanding will be redundant. So equating each of these brackets to be equal to 0. So I have x minus 3 equals 0. So here we have x minus 3 equals 0. So x is equal to positive 3. Change of sign. X minus 6 equals 0. So we have x is equal to positive 6. And x minus 2 equals 0. So x is equal to positive 2. There we go. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.